My goodness. Excuse me. That's fun. One to 40. I mean, 1 to 40. It's a lot of problems. Is that chemistry?
Hello. Hey.
Hi.
Hey, how you doing?
Good. How are you?
Pretty good. Yeah, we don't have to make like the tutoring today to be super long. I got your text.
Oh, okay, cool.
Yeah.
Alrighty. So,
Cool.
so I tried doing homework too
Yeah,
again
how was
on my
it?
own. I'm sorry?
How was the studying?
I mean, I tried.
Okay.
So, I tried doing homework 2 again on my own.
Cool.
I was
Okay.
able to do number 2 by myself, which is good.
Yeah,
But with
that's
number
good.
one, I'm still having trouble with like the algebra a little bit.
Number one. Wait, which one? Which one was that? Is that the one with the manipulation?
That's the one with Bernoulli's, and we're proving V1 and V2.
Oh, okay, that one. Yeah, I remember that. Yeah. Like what? So you know how to do it, or it's just like
I mean,
knowing.
I grasp the concept of how we're trying to isolate V2,
Okay.
but what I'm struggling with is the algebra. So let me share my screen. 1 second.
Let me see. Okay, I allowed you. Go ahead.
Okay, 1 second.
Oh yeah, I totally forgot. We didn't go over number one yesterday, or like the 14.13. I don't know if you need help with that one.
14.13. Is that the wire one?
Yeah, we kind of I kind of like stepped back. And I was like, oh, we just went over fluids yesterday in a sense.
Yeah, I was actually trying that one like just before we got on the Zoom, but I didn't get to finish. I watched the Young's modulus video.
Yeah, how was that? Yeah.
Um, I mean, I've dealt with strain and stress before, so I think I'll be able to do it if we just like
Okay.
go over it a little bit.
Okay,
So
we can do that.
we'll see with that. But okay, let me go to number 2 really quick. One second.
Okay.
So I looked at both your work and my professor's solutions, but I think I'm gonna go with my professor's just because she
You
uses
should,
H.
yeah.
She
Yep.
uses H, so it's just a little less confusing for me.
Yeah, just use that one. For most, like I'm trying to get like how your professor is doing it. Um,
Yeah.
hoping it's like similar, but yeah, and the lasting goal is to like do it the way she's doing it.
Mm-hmm. Okay. Do you see my screen?
Yeah.
Okay, so I'm at the point where, okay, yeah. First question is, so in the PowerPoint, it said, where is it? Oh, fuck. Why does it do that? Okay. Where is it? Okay. So you see here how it says, as the gas flows into a small cross section, it speeds up, equation of
Yeah.
continuity, I get. As it speeds up, the pressure decreases. So as the velocity speeds up, the pressure decreases. Is that true also for liquids, or is that just for gases?
Okay. So like this is like just like applying the Bernoulli. It's the Bernoulli should be with any fluid or gas. It doesn't matter.
Okay, so it's the same for liquids. Same rule
Yeah.
applies.
Same rule applies. Yeah.
Hold on 1 second. All right, cool. Now we can go to, I just wanted to clarify that before we continued. Okay, now,
Okay.
so where I'm having trouble was, I don't know, was I using,
Hmm.
I'm looking at my work that I wrote down. I don't know if I was using yours or hers. I think I was using hers.
Okay.
Because we
What's
couldn't
like
do,
what's the difference? I didn't really I couldn't tell because it's for this one, right? Number one.
so like what's different about hers is she uses rho with liquid. And with your work,
Okay.
I didn't do that.
I see. This is what she's doing. Okay, let me look at this for now. Hold on. P1, V1, and then she used rho liquid for the G and H, right?
Yeah, because this problem.
Oh, okay. I see I see what she did. Because you know how like the H, the potential energy part, this is the rho GH. The rho GH term, it cancels out for us, right?
Right,
It's
yeah.
like,
So I canceled out rho GH1 and rho GH2. I canceled that out.
yeah, and so even if we use like, it didn't matter if we use like rho gas or rho liquid, and that's why I was like looking at this and I was like, oh, okay, so that's what she's doing. And then if we used it, it would matter, but we didn't use it. Go with this though. Go with what she put, the rho liquid.
All right, so let me reread it. Hold on. There's a gas density rho that is moving inside the tube. This tube has a shape with two cross sections. Yes, that's why there are two velocities. Yes, you know that. Now note that there's a U-shaped tube that is connected. That's the picture you uploaded.
Yeah.
Yeah, I confirmed on the slides that it was the same one that you put, so we're good.
Okay.
Now use Bernoulli's equation to find the velocities in terms of other givens in the picture. So Bernoulli's equation, wrote that. I canceled the rho GH because they're at the same points. Remember that P1 and P2 are pressures on both ends of the tube. In this case, there are both. Yeah, that's what I didn't get. In this case, they are both the same pressure. So we can cancel P1 and P2.
I see what she did. And in mine, I put them as, let me see, P18. Let me just open up the one I have. Let me see. But the end goal should be the same. Maybe it's just the way she's assuming things. So what I did with mine was, let me read what she did, because like what I used was P1 minus P2. And in this case, they're both the same pressure. She did that. Okay.
See, but she didn't cancel out the rho GH and the rho GH. She canceled out the pressures.
She canceled out the pressure. Let's see. Okay. You want to solve for this. What's after this one? Like what happens after?
You want to solve this equation in terms of V1, you will need to write V2 in terms of V1, which I did that already. Now
okay, so she plugged this in.
in Bernoulli's equation.
Okay. H1 minus H2 is H. Okay.
Move the terms of V1 to one side.
Oh, I see. It's kind of like, if you think about it though, like the raw liquid G H1 minus H2, and it becomes H, right? Like that's what we use for Pascal's law. You could use this way. I would think like it's kind of like the journey here. You could use this. I think you should use this. Is what I'm saying. Like the way I did it is not like wrong. It's just another way.
Okay.
But what she did was because if you think about the P1 and P2, like you had to use that somewhere. How are they the same when you have like a difference in height? Right? Like if you have a difference in height, how are they the same? I mean, that's my argument. Like, but so I don't mean they're not open to atmosphere, right?
I think they are open.
Let me see.
Oh yeah, here it is. I don't know. It doesn't show that it's open. I mean.
Yeah, because like see like this P1, you see the P1 and P2?
Yeah.
It's like there's a difference in height. That's why there's a difference in pressure. So that's what, yeah, like.
I thought we were looking at V1 and V2 though, and they're at the same.
They're the same, but then like this bottom part, see like it's the way how you look at it. Because like this bottom part always, like if you ever see this, like was it the real life Venturi tube? Like when it's flowing here, this water, there's a liquid part here, it changes. Because it measures the pressure at the points up top. Like the point at V1 is the pressure is this P1, and then it's this level of the liquid is going to change depending on your pressure. And P2, that's at the second one. That's why they're both at 2. This can either go up or go down. Either way, like I said, it's what your professor did makes sense. Like, and what I did, it also makes sense. But then I think you should just go with what she put. If it makes sense to you. Does it make sense to you though?
Not really. I'm kind of confused.
Okay, let me unconfuse you. Like, so the way she did it, you know how like the P and the P2,
The
like
P1.
the P1 and P2, like you could cancel those. Because for me, I didn't I because the only difference is the P1 and P2 I use for the Pascal's law,
Mhm.
and then I canceled H1 H2 because they're the same in V1 and V2.
Right. But that makes sense to me.
But like what she did was the opposite of that.
Oh.
Yeah, like she pretty much canceled the P's, and then the H's are still there, and then she used that like that one sole H without a number as like the difference of the heights.
Damn, that's so confusing.
It's just the other way. Like I said, there's like two. Remember I said there's two ways of doing it,
Mm-hmm.
and then the way I showed was like one way, and then the
And
other
then
way,
she did it the
which
other
is
way.
funny. It's coincidental because she did it the other way. That's I get. That's where like you plug in the continuity equation after, not in the
But
beginning.
how did she cancel the pressures
I know, right?
if
Yeah,
the waters are different levels?
yeah. That would be a good question for her. If you can like maybe email her about that. I would
Yeah.
just say like it doesn't see like it depends on how you're because like that you're gonna get the same answer because that's just how like the Bernoulli equation works. It's kind
Mm-hmm.
of like the F equals ma.
Well, what makes more sense for me is having the heights the same for V1 and V2.
They are the same because at that point,
Canceling the rho GH1 and canceling the rho GH2.
yeah. And then what doesn't make sense is the pressures are canceled. Like why are they canceled? There's always pressure because there's a difference in height.
Exactly.
Yeah.
So
But like I
that's
said, like I'm not saying that she's what she has is like right or wrong, but if you were to let me see, like if you were to see this in an exam, there's always that thing, you know, with the theory, like because we're all just applying the Bernoulli.
yeah.
If you have the assumption correct, and then like the ending, like obviously you're proving this, you're probably gonna most likely gonna have to prove this in the exam, and then you know it already, so you just have to
Mhm.
memorize the steps or like know the steps
Yeah.
and then like the one thing I would do is have the assumption like bulleted up top, and then kind of like explain you know, not just the math but why you're doing it. And then
Yeah.
if she sees it, if she's a professor that's like, oh, you're, you know, you have to gauge what she likes or how she grades, because if she doesn't feel like what you put is correct because of your assumption is like not the same way as what she would have assumed,
Yeah.
then I think the
I mean, I
more
think if I get the answer right, even if I do it a different way, she'll still count it right.
yeah, that's like one thing you have to probably ask her like, oh, what if I show it this way? Because yeah, there's two ways of doing this problem, and that one way that she's like, it's just that assumption. Like if you ask her why did you cancel out the p's, you know, that's like the one thing I would probably ask her if you have
Yeah.
time to.
Yeah. Okay. Well then, so if we're doing it our way, where we cancel out the rho GH1 and cancel out the other rho GH2,
Yeah.
um, we're left with P1 plus 1/2 rho V1 squared equals P2 plus 1/2 rho, and then substitute V2 for that manipulated way of the continuity equation, which is V1A1 over A2, right?
Yep, that's correct. Yeah.
So that's the point I'm at. And then, so what I did from there was I moved P2 to the side of P1. So it's P1
Okay.
minus P2.
Okay.
And then I moved the 1/2 rho V1 squared over to the right side.
Yep, that's correct. Yeah.
So P1 minus, so I'm left with P1 minus P2 equals 1/2 rho, and then the substitution for V2, which is V1A1 over A2,
Yeah.
squared, minus, and then 1/2 rho V1 squared.
Yeah. So it sounds about right. Yeah. Okay.
And then so I'm stuck there because I'm not sure how to isolate V1.
Okay, so V1. So you still have those two things, like two terms where V1 is.
Yeah, it's
in it.
actually on your work, I think. Let me go to that. Hold on.
Yeah.
So you can see it better.
Oh, another suggestion I have, just in case it shows up, is how like you did it another way, our way, right?
Yeah.
Just send that to her and then ask her if she approves, so that you don't have like this discontinuity,
Yeah. Yeah, true.
Yeah. So like, oh, by the way, you approved it. It was correct. Yeah.
Yeah. Okay, so I'm at which point am I at? I think I'm right here. This part.
Yeah. Okay.
But then I moved P2, moved this P2 over here,
Okay.
and then I moved this over here on this
Yeah.
side.
Okay.
Then I canceled out the row GHs, right?
Yeah. Yeah.
Wait, it says row GH1 and then row GH1 again. I think
Yeah.
that's row GH2, right?
Because like it's H1 equals H2 at that level. Yeah.
Oh, okay. So then, yeah, I don't know how you got to here. I forgot.
Okay. So at that point, what I did is like I substituted the V2, right? Like from the continuity. And then like the 1/2, I moved the V 1/2 row V1 squared from the left hand side to the right hand side. And then they both have 1/2, so I just times the whole thing by 2. So that you have
Okay, so you times it by 2 to cancel out both 1/2s.
Yeah, both 1/2 should cancel out because it's on the other side.
Okay, and then put the times 2 on the P1 sides. Okay, that makes sense. So 2 and then P1 minus P2. And then so we're left with row V1 A1 over A2 squared minus row V1 squared.
Yeah.
Okay, and then from there, what should I do?
Okay, from where to where? From that to the other one?
So I'm now here. Now
Okay.
I'm at this point. So how did
Okay.
you go from this point to this point?
Okay. So like here, I mean, you could have done it a different way, because the one thing I do is like I just want to work with non-fractions. So like anything fractions, like any fraction, I would just like move it up.
Oh yeah, you times it by A2 because of the bottom, right?
Yeah.
To cancel out the A2 and then put the A2 on this side.
Right? Yeah. How did she get actually, yeah, you could do that. Never mind. Yeah. Because she had the row liquid GH and the H becomes H1, yeah. Yeah. I still can't get away. It's like the P's disappear. It's like weird.
P1, P2, and then A2, all right, and then equals row V1, A1 squared. Wait,
What was that?
can we multiply the A2? Oh, wait.
You can, yeah.
Because you have to multiply it with the square?
Yeah, the whole anything in the bottom, like just move it up, like multiply it.
Oh, okay, yeah, because I forgot to distribute the square.
Okay.
Let me write that in. Okay, yeah, that makes sense. All right. Minus P V1. Is that what we have here? Let me see. Yeah, and then row V1. Oh, I think it's written out differently, but let me see.
Okay.
Okay, I'm confused how you got like right here.
Right there. Okay. So you know how like we multiplied the A2, right? Like across the board.
Yeah, so what I have is this part is the same. I have this right here.
You got that left hand. Okay.
Yeah, but
So,
what
okay.
I have on my right side is row V1A1 squared.
Okay.
V1 squared, actually, let me distribute out the square.
Okay.
So V1 squared, A1 squared minus row V1 squared. Oh, did you take out a row v1 squared? Is that what you did?
Yeah, because the row itself is like the same, and the v1 squared is the same, plus and minus, both
Mm,
terms.
okay, I'm gonna be like factor out row v1 squared.
Yeah,
Okay.
pretty much unfoil it or whatever, factor out. Yeah, factor out sounds better.
Okay, cool. So then now you have row v1 squared left with a1 squared minus, wait, where'd this come from?
Which one?
Right here? Because I thought this canceled out with
It,
this.
it canceled out only on the plus term. The minus term doesn't have it at the bottom. You didn't have it, right? The rho v1 squared
Oh,
minus.
you had to put it with the bottom one?
Yeah, it's on its own. Like the second term, the minus rho v1 squared times a2 squared.
Oh, fuck. That's confusing.
It's all just math. Yeah.
Yeah. Fuck. All right. So the a2 squared had to be applied to the first term and then minus the other term as well.
Yeah. If you distribute it, it would like make more sense. Like the way I did it, it's harder to. I didn't want to show that stuff. It's just like pretty much it's like super big. Yeah.
Mm.
You got it though. You got it. I think it's just that the division part. You don't have a division on like the minus, so that's why a2 is like still there.
So the a2 squared is still with the row v1 squared.
Pretty much, yeah. Because you don't have a fraction to cancel it out.
You're right. Okay. All right. Hold on. Let me write that in.
Yeah, I think your professor likes to do this kind of stuff. Like, she doesn't. I've seen the practice one that you showed yesterday.
Mm-hmm.
It's like a brutal way of testing you guys in this type of work. Because like you shouldn't like. For me, I mean, if I were like like teach this class, it's more of like you understand the equation and then using it, like applying it, like not like, oh, let's figure out derivations and qualitative questions for you guys. It doesn't make sense. You're gonna get more confused.
Yeah.
And out there in the field, you're not, you know what I mean? Like it's very theoretical.
Yeah.
It's weird. Whatever. Different.
Okay. So factor out row v1 squared. So we're left with row v1 squared, and then we have the a1 squared minus a2 squared. That makes sense now.
Awesome. Yeah.
Cool. And then, all right, so let me make sure I have it written the same. Yeah, wait, yeah, I put the row in front of this, but it's the same thing.
Yeah.
Okay, cool. I got that down. Cool. That's the last of it?
Pretty much. I mean, if you look at it, like you already have pretty much the whole thing, right? That V1's isolated. You just have to move something.
So
like,
we're gonna have to move this. Oh yeah, you just divide it.
Yeah, it's already there. Yeah. That's it.
So divide the row a1 squared minus a2 squared, right?
Yeah.
Cancel it out. So we're left, hold on, okay. By row a1 squared minus a2 squared.
I want to see like what she does on this part. I think everything else is the same. It looks like everything's the same except for like the swap.
Mm-hmm. I really don't get how people can do this for fun.
I know, right? It's not. The thing is like, what's it called? It's more like a mathematician's thought of process. It's.
Yeah.
I would say here. I guess for my side, I don't know how like you guys do it for geologists, but for like the way I would apply this is you obviously need to know like the equation that you're gonna like, that you will use, like because like everything is more general, and then you just plug things in. But then again, like you're already given the equation, so that's why like it doesn't make sense. In the beginning, it makes sense. You do it only one time, like to prove to yourself, but you'll never apply it like proving to yourself.
Yeah, because the equation is just gonna be there.
Exactly. Yeah.
Oh yeah. Okay, so all right, I get it now. I get that part, but I know
That's
there's
good.
another part because now we have to do V2, right?
V2, very simple. Yeah, it's pretty much a swap, same exact thing.
All right, cool.
Okay.
Moving on to the next part.
Okay.
Do we look at what my teacher said first?
Yeah, like I want to see like there's a few words there I want to like kind of review. So let me just read that part where she said she's gonna cancel it. Let me see. Remember that P1 are the pressures at both ends of this tube. In this case, they are both the same pressure. So she's saying it is both ends of this tube, right?
She's saying what?
She's saying that it is at both ends. So she's assuming it's open to the outside.
Hmm. Hmm.
So that's what she's saying. So that
So
if
then
that's if that
your
so
pressure.
if that's the case, then yeah, it would work. And then like after this, what does she do? Like when she isolates the V1, like so she did that one. Okay.
Okay, she gets the. Wait, we isolated V1, right?
Yeah, it's the same thing as this. The V2, you need to put the V2 so that you only have V1. So you have V1 here, right? You have V1 in the left hand side, and then after that, like she combined it on the left hand side, and then like she times it by 2, and it divided by rho. She actually forgot her other row. She forgot her row gas, but it's supposed to be at the bottom.
Oh yeah.
Yeah, but yeah, like that makes sense. Everything else is the same. There's only one difference. It's the H and then the P.
Yeah.
That's the only difference.
Yeah.
Just confirm with her. I'm pretty sure your answer is right. So.
Okay. Should I do that right now?
I don't know. Does she usually? I think it would be best if it's before tomorrow because you guys have the exam.
Yeah.
Yeah.
Here, take a photo of it. 1 second. Actually, I think I forgot to write in something.
Okay.
Yeah, I forgot to write in the A2 in front of it. Hold on.
Okay.
Yeah, I'm gonna email it to her right now. So hopefully she can reply while we're working on something else so we can see.
Yeah, that'll be good. I do want to because like yeah, if she agrees with what you're saying, she's like, oh yeah, as long as you get the right equation, and usually would say that. Hopefully she says that.
Wait,
Okay, cool.
took out the. Why did we take out the A2 again? Because it was already squared.
Yeah, it's already squared, so you squared it. So it's like the inverse of a square.
Oh wait. Yeah, because we square rooted the square, so it canceled it out, right?
Yeah.
So we bring it outside.
You bring it outside.
So A2 square root.
Yeah.
Okay. Getting it.
Even if she says like you do it her way, you do understand her way though, right?
Not really.
It's always good. Like, see, like that's my suggestion. Like, it's always good to know it like two different ways. I mean, not just two, but if there's like multiple ways of doing something, because like you just have to know when it applies. Like my way, maybe it applies in some cases. Her way, if she says, "Yes, this is the be all end all,"
Yeah.
like so use my way. It's good to understand her. The only difference, like I said, is I think that it'd be better if you kind of write like the way she did it, and then now you understand my way, right? Like you understand my
Yeah,
way.
I understand your way for sure. So at least on the exam, I mean, I'm still gonna ask her to show me her way, but if I don't understand her way, I at least know your way. So
Okay, cool.
I'll
But
just use.
like that's just the one thing. Like if you have to write something down so that you don't get knocked down points, it's just the way you did it is you didn't assume the p's, because that's the only difference. The p's don't cancel out using our way, and then the h is the one that cancels, because then you assume the point where your Bernoulli is you assumed it at where the I guess you could say the center line of the tube.
Mhm.
So that it kind of justifies like, oh, okay, now you kind of understand what the heck's going on.
Yeah. So like, did she assume that the tubes were open and we assumed they were closed, or no?
Yeah, she assumed the tubes were open on both ends, so that's why it's atmospheric.
Mm.
So if it's P atmospheric, then yes, they're the same. We kind of did the same problem with that. Like I think the second one, second problem is when it's open to the outside to the system, it's always atmospheric. So obviously it cancels, and then the H's will be the difference of the height of the water. So that way works. Yeah, that way works for sure. Just know what the heck she assumed.
Yeah. Okay. Hold on.
Yeah.
Let me email her.
Yeah, it's not that bad. Like if you have time, I would probably like. I mean, we don't even know if this question is gonna be in the exam.
Yeah, true. Probably
Yeah.
is though. She didn't give too many problems, so I'm assuming
Yeah.
all the problems she's giving are gonna be on them on the exam.
Yeah. Is there another like derivation problem, or is this? I didn't actually look at the other part, the other review problems.
Um, I don't know.
This is yeah, like most of these are not that bad.
I hate that Zoom shows this thing. How do I hide this?
Which one?
This like bar here.
At the top, the green.
Like how do I move this so I can go to my
You can minimize your
okay, okay. Cool. There we go.
okay.
Let me see what her email is because I don't know. It's like really long. Zara Hushman.
Dr. Hushman. Okay, so that okay, I see.
Hush. Oh, oops. Z Hushmand.
So is she like
I don't know where she's.
Iranian
She's
or
born.
Iranian? I think she sounds Iranian.
Like where?
Iranian, Iran.
Ah.
Maybe I don't know. I'm just guessing. I mean, you're the one that knows.
I haven't asked her where she's from. I don't want to be rude.
No, like the way she, what I mean. Never mind.
Oh, like her accent?
Yeah, there you go. Or like, are you guys doing like, what is it called? Like a Zoom live or Zoom asynchronous?
It's like it's Zoom.
But is it live though?
Yeah, it's live.
Okay, and she doesn't show up like her video.
I mean, she does do a video. I just can't tell her what her accent's from.
Okay.
Is that what you're saying, or what do you mean?
Like, cause like most of my professors are Iranian, and most of the UCSD professors, like, either they're like from either Chinese or Korean or Iranian.
Like white. She's like really light skinned, blonde hair, blue eyes, but she talks like she's from like the Middle East or something.
There you go. This is probably Iranian for the most part.
Yeah.
They're really smart, that's why.
Oh, they are?
Yeah.
Okay, so I'm gonna be like, I was wondering if the way I did number 1 is correct. I noticed that you canceled the pressures,
Yeah.
but I canceled the height
H's.
because V1 and V2 were at the same lengths, at the same points.
Because
Or
like this is how I would phrase it. Because like you know how like you have a difference in pressure in H1 and H2.
yeah.
So that's why I didn't cancel P1 and P2. That's how I would phrase it. And then The height that I chose is at the where the gas layer is, not
Wait,
where
say
the
that
liquid
again.
layer.
Say it
Okay,
again.
so the first thing I would say is I noticed that you canceled the p's, but then
Hold on.
from
One second, one second.
okay.
Here, I'm gonna try.
So like to abridge it, just say that say your part first. Say that I would like to confirm if my answer is correct. Something like that, along those lines.
Uh-huh.
The way I assumed my my derivations or are whatever,
Hmm.
like the pressures do not cancel out because there's a difference in height of the water, and the
Okay.
h's.
So I did not cancel the pressures.
Yeah,
Because,
because there's a difference in height in the water fluid. And then the second thing that you assume is for the gas layer, I had the heights. The heights were at the same level, so that's why the h's can the because you know how like the rho gh the h's cancel. I wouldn't say the h's cancel. I would say the potential energy term cancels
potential energy.
because that's the rho gh term. That's the potential energy. Yeah.
I'm just gonna be like the potential energies canceled.
Yeah, but my pressure energy does not because there's a difference in height at the water layer.
I was wondering, okay. Hold on.
And then like, obviously like you can clip your stuff in there.
So I did not cancel the pressures because there's a difference in height of the water.
Yeah.
For the gas area, I have the heights at the same level. So that's why the potential energy,
Potential energy cancel, yeah.
just like that.
Exactly like that. And I would and then like ask her maybe in the beginning of this because like you
Yeah.
want to know, can you confirm if my approach is correct? That's
Yeah.
it.
Oh yeah. I was wondering if the way I did number one is correct.
Perfect. Yeah. And then just let me know what she says.
Okay. Choose from photo library. All right, sent. Cool.
Yeah.
All right, so we got the V1 part. Now, for V2.
Well, it's not bad, yeah. You're gonna do V2?
Yeah. Problem one continued, okay? So we have the same equation. If you want to solve this equation in terms of V1, you will need to rewrite V2 in terms of V1. Well, isn't that what we already did?
Yeah, it's pretty much the same thing. Like, you just swap the V's.
Oh, in the continuity equation.
Yeah, that's the only time it changes. Like after you do V1, just swap them. Everywhere you see it. And you should get the same thing, but like different location.
Wait, so did she do V2 first?
I think what she did first was like
Yeah, she did V2 first, but we did V1 first.
she did the same thing. Like the V2 is isolated, but then like you need V1. Like she solved for V1 after. She isolated V2 for the continuity, but then she solved for V1.
Yeah. Oh, okay. So she just did the V2 first and then did V1. But we
Yeah.
did V1 first and then find V2.
I think we still found V1. It's the same thing. The V2 was isolated and the continuity for us first time, and then we solved for.
Oh, right.
Yeah.
What? I'm confused. Oh my God.
Which one?
Because, okay, I know what we did, but why does she have like, oh, wait, remember that P? Oh, all of this is just explaining why she canceled the P's, right?
Exactly.
And then this is like where we started what we did.
Pretty much, yeah. It's pretty much what I did. I did assumptions first. And
Yeah.
this is what she explained her assumptions.
This is where we continue. Okay, now that we have V1, We can use continuity equation again to find V2. So V2.
And then it's just that, like she just swapped it, that's it. She just swapped her equation. But then like looking at this, let me see, looking at that, it should be A1, like on the right hand side. Because it's V2, right? Like it's supposed to be V2 equals A1, not A2. It doesn't really matter though.
Oh, like right here should be a 1?
Yeah, right?
I don't know. Wait. Because we're isolating V2. That looks correct.
Yeah, but then like she's saying up top that now we need to find V2, which she did, but then like you're supposed to isolate.
Oh yeah, because then it's the exact same thing as V1.
Exactly, yeah. So the right hand side should be A1. Like A1 times that square root thing.
Okay. You're right, yeah. Good
What
catch.
does she say over here? She says if the term inside the square root should be positive. Okay, we know that we can. Okay, we know that. You know, there's some things here. Maybe like if she does ask you because she seems like she loves these like conceptual, you know, question stuff. She's like saying so many things where make sure that you know this. So maybe like, do you know what she's saying there? Like important point.
No.
So
Point. Inside the square root should be positive. We know that we can't have a negative number inside the square root.
Obviously, duh, yeah. But physically, what does it mean? Some of you have the denominator inside the square root as A2 squared minus A1. I don't think we have that one. If you look at the picture, you will.
Denominator inside the square root as okay. If you look at the picture.
Bigger cross section, yeah. It should be the bigger cross section first.
I don't get what she's saying, but okay. Oh yeah, I get it. Like the big minus the small, so it comes out to a positive number.
That's what she's saying, yeah. Okay. So like, you just know that's what makes it negative if it's swap the areas. Everything else is, you know, pretty easy. Like the numerator is always gonna be positive. But if you swap like the denominator,
things are always like for this part, this bottom part.
Yeah, if you swap A1 and A2, you're gonna get like, because A1 is bigger than A2, right?
Mm-hmm. So we always put the bigger minus the smaller.
Yeah, she's just saying like if you were to ask a question, what would happen, you know? like if you swap these, and then like does this make physical sense? Something I can imagine like if she likes conceptual stuff, she would ask you that. You know what I mean? Like I'm just trying to like anticipate like her mindset.
Yeah. All right, cool.
But if not, then whatever, you know.
Yeah. So I surprisingly got this one, but it's not even that hard. So whatever.
Yeah, this one is really applying it, which is really the best way of teaching it.
Yeah, sure.
Okay.
Okay. Now let's move on to what was I working on? I was working on she said the hydraulic lift was gonna be on the exam.
Hydraulic, what number is that?
Example 1411. I think you did it. I'm not sure. Let me see.
1411, yeah, I think I did.
It was like the first one you did because it was using Young's modulus.
Those ones are fun. I don't know if like what part of it doesn't make sense.
Well, all I got on that part was watching the video. I didn't even like really try it, to be honest.
Do you get first of all, do you understand the concept?
Sort of.
Yeah, because there's two sides of the coin here, right? Like I can't kind of like this class is like two sides of the coin. You have like the solids part, right? And then you have the liquids or like gas. Gas is kind of like a liquid, like fluid. It's like a fluid.
Mm-hmm.
But then, like,
I'm sorry.
But yeah, so you know that, right? There's the solids and then there's the fluids.
Mm-hmm.
It's kind of like those two sides of the coin. And then like that solids part is all elasticity. Like that's like stresses, like
stresses and
strains, yeah, all that good stuff. And then the fluids or gas is all the water or like whatever liquid you have. which is like Bernoulli and everything else later on. So
Mhm.
like this Young's modulus is on that solids part. Like this is where you apply it when it's a solid, which is really interesting because then you get a appreciation of like analyzing the I guess the physics of materials. Like you have the solid, because there's solid, liquid, gas, right? Obviously, and
Mhm.
solids will always have these like Young's modulus. It's always up. You're always gonna find like it's gonna deform, and you have strains, right? Right.
Yeah. Uh-huh.
And then like this Young's modulus is the essence of this Young's modulus is like stiffness.
Right.
Like
Yeah, I watched the video. Like there's like
you got it,
elasticity
yeah,
and it's a point, and then it's plastic deformation, which is irreversible.
exactly,
Elasticity
yeah.
bounces back like the rebound theory. So it goes back to its original form. But once you break the elasticity point, it's plastic deformation and that's irreversible.
Yep. And then this E is like, well, for now, for what we have in this class, this E is like in the elastic region. This only applies in elastic for now.
Oh, okay. Let me write that. Okay, so E is elastic.
Yeah. Later on, like if you ever like get interested or like curious, like the plastic region actually has its own E, but then yeah, you'll never really want to do that because it doesn't really exist. It's like theoretical. Like this elastic E, which is Young's modulus, is the one thing that everyone uses because like it's everything is elastic. Everyone things that get deformed, it's easily like measurable in a sense.
Mm-hmm. Honestly, I don't know if this will be on the exam.
The elastic part.
Mm-hmm.
Okay. I mean, it's not that bad. That would be good if it's not. Then it's just all fluids.
Yeah.
Did she say that though, or I don't know. I don't know. Like,
Sure.
cause like all I saw from the problems were like elasticity is that like manipulating that equation pretty much.
Mm-hmm. Why aren't my sent items showing on here? I sent it through my phone.
Hmm.
What the heck? Oh my God, I hate this so much. I literally sent it through my phone and it's not showing here on my laptop. The question.
That's weird.
Oh,
What, an
oh,
email? Oh, there you go.
oh. No.
Uh, oh.
No. No. Shit, man. This is wasting time.
So, anyways, like, so the elasticity part, you do get it though, in case it is in the exam.
Um, Not really. But really what I should go over is the hydraulic lift because I know for sure that's going to be on the exam.
Okay, hydraulic lift. You said 1411?
Yeah, example 1411. So this example.
Oh, I see, I see. Let me, water flow requires water speed. This is just Bernoulli, right? What is the reading of the pressure gauge? Yeah, it's just Bernoulli.
Okay,
Because
because
you
it
have,
says gauge pressure. Does that make a difference?
what is the reading of the gauge? And remember the difference between absolute and gauge?
Gauge is like the leftover pressure after absolute and atmospheric is applied, right?
Yeah, the only difference there is like the atmospheric pressure. You just have to know which one is the one, which side of the, like, you know what I mean? Like, I think it's like gauge equals, or absolute equals gauge plus atmospheric. I think that's what that is.
Mm, hold on.
But like, in terms of like applying that, like here, all you have to do here,
Oh
say
yeah,
the
yeah.
water,
Gauge pressure is P minus 1 ATM.
is that absolute or gauge?
The gauge. The gauge
Is
is
abs,
P minus 1 ATM. And 1
yeah.
ATM is 101.3 kilopascals.
Okay, so gauge is the one on like the isolated pressure. Yeah, that was right. So gauge equals P plus or P minus 8 P ATM.
Mm-hmm. So PG.
So absolute is P gauge plus P ATM. That's the one I remember. Yep.
Is
Yeah.
absolute the P?
The absolute is the P. Yeah.
Okay, let me write that.
I would just I usually put like subscripts for these. Like I would put like P abs and equals P gauge plus P ATM. Or if you want to do the other way, P gauge equals P absolute minus P ATM.
Okay, yeah, you're right. Okay. All right, and then here's the work or whatever it says. Treat the water as an ideal fluid, obeying Bernoulli's equation.
Yep,
Consider a
okay.
line connecting point 1 in the lower pipe with point 2, okay?
Okay, it's already solved. Okay, that's good.
Bernoulli's equation relates the pressure, fluid speed, and heights at points 1 and 2. It's easily solved for the pressure P2 at point 2.
Okay, yeah, this is what we do. Yeah, we apply it.
Bernoulli's equation?
It's Bernoulli's equation. Yeah, it's just pretty much applying it. I like these should be like the easy ones because like, but let me know like, what part doesn't make sense.
Okay, so P, okay, one half, what's Y, H?
Yeah,
Wait, this looks different from Bernoulli's that I know.
it is. There's two. It should be the energy form, right? This is the energy form. It should be the same one.
Oh, we just moved the 2 and this to the other side.
Yeah. Anything
Oh.
minus is moved. Yeah.
Mm-hmm.
And then you see this one here. So now it says the pressure at point 1. This is the part where it matters, like the equation we talked about. Is like they're adding 1 atmospheric, right? 1 atmosphere because they want the absolute. You solve for the pressure at point 1 is you solve for the 75, right? You solve for the 75 and then you add the atmospheric, which is 1. Does that make sense or?
No.
Okay, so like he wants or the equation itself is asking you like find the pressure at 2, right? That's what it's asking.
Yeah.
Yeah.
The gauge pressure, no?
Yeah, try to go up. It says gauge, yeah, pressure gauge in the upper pipe, the 2.
So
And then
what about the pressure gauge makes it different from just finding regular pressure?
I see. Right. So that question itself is like when you're solving for the Bernoulli, um, like you're gonna have to let me see, like because one of them is when you're getting it from a gauge, it's gauge pressure. When you're and then if you're solving it for like, and then that's why it matters because then if it's asking you is this absolute, then uh, you have to add like 1 ATM if you have gauge pressure, which is from a gauge, like a reading. And then the P1 is gauge pressure, right? Like P1 itself.
What? I'm sorry?
P1 is gauge, right? Like if go scroll up. I want to see what P1 says. So you know how like P1 here is 75 kilopascals?
Uh-huh.
So when you add, that's gauge pressure, right? That's from a reading.
Is it?
Yeah, it is.
Okay, so kilopascals is gauge pressure.
Not the unit, but like what it is right now, 75 kilopascals, yeah.
That's gauge pressure.
Because gauge pressure is from a reading, right? You're reading it from a dial, it's gauged. That's what a gauge is.
Uh-huh.
And then for you to like, you're always wanting to use the Bernoulli in absolute pressures. You always want to like solve it for absolute pressures.
Right. So we're converting the 75 to absolute?
Yeah. So what does that mean? That means you add 1 atmospheric, right?
Okay, let me write that. Convert 75 kilopascals to absolute.
And that's in words. But when you say convert the gauge into like absolute, you just add 1 atmosphere or like 101, 300 pascals or 101.3 kilopascals.
Okay, so add 1 ATM.
Yeah. And then convert the 1 ATM. Yeah, you know 1 ATM already. Like that's just 101.3 kilopascals.
Right. Okay, so then we do 75 plus 101.3.
Yeah. Or whatever the number is.
And that is 101.3 plus 75. 176.3.
Yeah, and then scroll down. I want to see what it says. Like to where it tells you that right here at the bottom, the last paragraph. The pressure at point 1 is 75 gauge plus the absolute gives you 176, 300 pascals, right?
Where does it say that?
At the bottom, like the last paragraph.
Pressure point 1 is okay. Okay. Oh wait, what?
Right? Yeah. And then this, which what? Which part?
I thought, what the hell? This is so confusing.
What part?
I thought 1 ATM was 101.3 kilopascals. So I
It is.
added
It is.
1.3 pascals to 75.
What?
Why?
Say that again. Say that again. What?
1 ATM equals 101.3 kilopascals, right?
Not always. It's not always. Let me see what it actually is from what they assume. Let me see what they assume first. I think they assume 101.3. That's what they assume. Yeah.
Oh, and then you convert the kilopascals to pascals.
Exactly.
That's what they did.
Yeah. They're pretty much screwing with you. They have 3 different like units.
God, this is so fucking annoying. I hate it.
Yeah, units is our. It could be your friend. It could be your enemy, foe, friend or foe, whatever. But I feel like in the online thing, because you don't have to memorize it, right? You can just Google it.
Yeah. Okay.
But yeah, definitely, units. Keep them consistent. Oh yeah, I didn't really tell you this, but like the way I usually would like attack Bernoulli's is I keep everything basic. You know what that means?
No.
Like I go like with like the standard unit for like pressure, like Pascal. I don't go like kilo. I don't go like I don't simplify it. Like if it is kilo, I would convert it to pascals. And if it's like if it's kilogram, I still stick with kilograms. And if it's like meters, millimeters, centimeters, I stick with meters.
Mm-hmm.
The reason why is
we're always converting it to pascals, whether it's kilo or any kind of pascal.
Stick with
regular pascal.
For pressure. Yeah, the reason why is like it's gonna screw with you if you use different like levels of that unit. Except for kilogram. Don't make kilogram grams. Make it kilogram because of the Newton. Newton should also be in Newton, not kilonewton.
Our units.
Because like pascals, right, is Newton per meter squared. So that's why I stick with Newton.
Mm-hmm. Okay. All right. So then we converted it. Okay, I get this now. I can now use the above expression for P2 to calculate P2. So all they did was they substituted this 176, 300 into P1.
Exactly. And then you only use Bernoulli's for absolute. That's the concept here.
Okay, hold on, let me write that. Bernoulli's is only used for absolute.
Yeah, and then if you want gauge, you have to finagle it like what they did.
So you have to, if they give you gauge, you have to convert it to absolute so you can use Bernoulli's.
Yeah, always remember that one because if you use like gauge, like you're gonna get a wrong answer. Yeah.
I see.
And that's why after they used it, they minus the the 1 ATM to get it back.
Yeah.
Where it's supposed, what it's asking, the gauge.
Okay. Makes sense now.
Yeah. I think that's probably the only difference here. Like it's pretty much everything you know, and just adding that part, the gauge versus absolute.
Yeah.
That's it.
Okay. Well, I think that's fine. I'm just gonna ask her about the Young's modulus, and then I'll confirm about the pressure and the height thing on homework 2, and I'll let you know what it says about that.
Yeah, I mean, it shouldn't be like for the exam. So you're good with all those concepts, right? It shouldn't be that hard. Is what I'm saying. I mean, it's your first exam, right?
Yeah, I mean, if it's on what we've learned, what we've been going over, I should be fine. But if there's anything else, I mean, I'm pretty sure I'm not going to be able to do it.
That was I hate professors like that. Maybe you could just, confirm with
I
her
was
as well.
gonna
I
ask
usually,
you, like, what exact topics are going to be on the exam?
yeah.
Like verbatim, like what exact equations? And I wish you would give that. I wish you would give like, these are the only equations you need for this exam. So that at least
Like,
helps me know like what equations to practice. You know what I mean?
yeah. I mean, for sure, if she's super nice or like regular,
I don't know. I mean,
like she would
I went
definitely do
there office
that.
hours and like I was like how I am with you, like not knowing anything, and she was like getting frustrated
Just
with me.
getting frustrated,
Yeah.
like serious kind. Because the thing is, like, that's her job, yeah.
Yeah. Cause she was like, have you even read the PowerPoints at all? And I was
I don't like that kind of tone.
yeah, and I was like, yeah, like several times. She
Yeah,
was
that's
like,
why I'm here because it doesn't make
like it.
sense.
She was like, well, it doesn't seem like it. And I was like,
Doesn't
I read
seem
it
like
like
it.
at least 6 times, but I don't know what I'm doing. I'm sorry, but I'm not good at this kind of thing.
Okay, I see.
Yeah,
In
she's
my
kind of
mind, like
honestly.
it seems like see, like if she's already like that, I'm
Hmm.
hoping she does answer your email. Like the thing that sucks. Are there other professors or is it just her?
I don't know. And see, I signed up with a different professor, but I think something happened with that professor because then I got a new one. I got her.
It's okay. I mean, there should be more than one. I mean, this is like a physics class, Like it's not
Yeah.
like a major. Yeah.
Yeah.
Uh, well, whatever. I'm pretty sure you're gonna survive. I'm hoping you can still get an A. I always shoot for A. So,
Yeah, I really hope so too. But if,
but
honestly, as long as I just pass, I don't really care.
okay. So the goal is just to pass. Thing, yeah. It's always dependent on the professor. Honestly, it's not about like you knowing it. Everyone can know it.
Hmm.
Like the grade in these ones that's why I'm always careful about like the professors I pick, especially the I mean this doesn't matter as much, but like for your major ones.
Yeah.
Yeah. But yeah, I think you'll survive. I mean, I'll be here to like guide you. I mean, this class, fluid dynamics is like my thing. I like doing it. And then thermal, we haven't gotten to thermal yet, right?
Mm,
But I
no.
feel like, oh yeah, I think chapter 18 is thermal. We're gonna get to. I did take a look at that. Have you had a chance to look at it?
The thermal stuff?
Yeah. It's not as bad. It's the basic stuff is not bad, but then if I didn't look ahead, but just looking at 18, it's pretty much like chemistry. If you've taken high advanced chemistry, it's gonna be a breeze, is what I'm saying.
The thermal, like the thermal's easier?
It's like than what we're doing right now. If you've like taken advanced chemistry, yeah, it's pretty much that.
Well, the only chemistries I've taken are Chem 1 and Chem 2.
You'll be fine.
Like I've
You'll,
taken both. Like I'm pretty decent at chemistry. Better at chemistry than this, that's for sure.
oh, for real? Okay. Yeah, it should be a breeze for you. Like, I did take a look at it, and then all the the ideal gas law, all that kind of good stuff, and Avogadro, and then if I for what is it? That's the next thing. After the exam, you probably just like screw it. I'll just do it tomorrow. But I'll I'll take a look at 18 and maybe did you want to like just do weekends or how did you want to like proceed?
Mm, yeah. Well,
Yeah.
maybe like one during the week and then one on the weekend.
Okay. I'll let you like decide that one. Like I don't know
I'll
how
let you know though. I'll let you know by tomorrow.
okay. Yeah, I'm
I'll let
super
you know.
flexible. I
So
was
can
just wondering because
I'm sorry.
you know how let me say how like when you schedule like the first time you schedule the tutor, I always ask everyone this. But do you usually want me to like schedule or do you want to schedule it yourself?
I'd prefer you schedule it.
Okay, so I'll do that. And then like what about the 1.5 and 1? Did you just want 1 or 1.5 every time?
Um, let's do one because I only have 10 hours. Well, like when I
Okay.
started, I had 10 hours.
That's
So
fine.
I want to use
Let's
10 hours for the whole semester.
yeah. Let's just do that. I mean, my end goal is not really that part. It's just more of like, do you really understand it, and then you don't have to be super passionate about it, but like I'm hoping that after you like learn this, that's my goal. Is like we can spend as much time as possible, and then just count that part, as like one. But we can always spend more time. That's why the Zoom is. I always put the Zoom as like 30 minutes longer.
Mhm.
So, and if you understand it, if you need more time, then you can always just do like we could do another one. But yeah, let's do that. Just 1 hour for each
Yeah, and if
session.
it's like a few minutes over, then
Doesn't matter for me really.
okay,
Okay.
cool. Thank you.
Okay, so yeah, let me know what day, like the next one. We don't have to, like,
Okay.
usually I would schedule it like throughout the whole semester, but let's
Mhm.
just play it by ear.
I'm thinking Wednesdays, like one on Wednesday and then maybe one on like Saturday. Or you know what?
Okay.
Maybe like once a week, like on
Okay.
Wednesdays, because I have this class Mondays and Wednesdays at
Okay,
11
so
a.m. So I
so you
think if I
want
have it after
okay.
Wednesdays, after I have this class, while it's fresh in my head, like we can go
Yeah,
over
for
like
real, yeah.
yeah. And then on weeks that I have exams, we can do 2 lessons. We can do one on
That makes
Wednesday
sense.
and then another one on like Saturday or Sunday. So
Okay.
that way,
For
like,
for
the fresh.
Wednesday though, like are you good with this time on Wednesday? Like maybe a little bit later, or what do you want on like what time usually on Wednesday?
Yes, Wednesday, I just have that class at 11 in the morning, my time. And then I have a class at 6 p.m. my time. So anytime in between, I'm available,
Oh, okay.
which
Let's
is
see, let's see.
10, between 10 and 5
Okay.
for you.
Let's yeah, Wednesday for me anytime after like usually after 4 or let's just make it 4 to 5 my time.
4 to 5 your time, which is 5 to 6 my time.
Yeah, like right before your other one, yeah.
Okay. Yeah, that works.
Cool. And then like Saturday doesn't matter, anytime.
Okay. And then Saturdays we'll just do on weeks that I have exams coming up.
Yeah.
Yeah.
So that one we'll play it by ear. Just let me know. For this next one, it's gonna be Wednesday.
Wednesday at 5 my time, 4 your time.
Yeah.
Okay.
Yep.
That
So
works.
wait, you want me to schedule that one, right? You said.
Yes.
Okay, I'll do that like sometime later this week. Cool. That sounds good. So let me know. Let me know if you get a
Okay.
or
All
not.
right,
Yeah.
then I'll let you know what my professor says.
Perfect. I awesome. Thank you.
All right, thank you.
Yep.
Bye.